All right, welcome to Concept D. This is going to be working on balancing redox reactions using the half reaction method. And this is really going to build upon what we've done the last couple of units with assigning oxidation numbers and looking at half reactions. So we can balance redox reactions by identifying the elements that are oxidized and reduced and then writing their half reactions. And this is a 7-step process that we're going to be doing. First off, you have to assign oxidation numbers to all the elements involved. Again, we've done this for a couple of lessons now. So remember, anything by itself is going to be 0, so copper is 0. Go ahead, fill in HNO3. Try out, so pause the video and try out CuNO3 too. You should calculate these oxidation numbers. NO should be -2 and +2, then finally H2O. So now we have all of our oxidation numbers. You're going to see that only 2 have changed. Copper has gone from 0 to +2, and then nitrogen has gone from +5 to +2. And yes, nitrogen, some of them have stayed the same, some of the atoms. However, we are concerned with the atoms that have gone from +5 to +2. All right, so identify the elements that are oxidized or reduced. Because copper has gone from 0 to +2, it has lost electrons, so it's oxidized. And then nitrogen, which has gone from +5 to +2, has been reduced, so it has gained electrons. So now in order to work on balancing it using the half reaction method, we have to write half reactions. All right, so this is kind of the backbone of our 2 half reactions, and then we're going to fill in the electrons. So remember, oxidation is the loss of electrons, so we need to place this on the right-hand side as a product. And then we also now need to look at the number of electrons lost. So we went from 0 to +2, so that means we lost 2 electrons. And then for nitrogen, because it's reduction and a gain of electrons, we're going to put that on the reactant side, or on the left-hand side of the equation. And to go from +5 to +2, I've had to gain 3 electrons. All right, so that's one of the main first parts here is writing the 2 half reactions. Now this part is going to be new. Now we want to actually make sure that the number of electrons lost is equal to the number of electrons gained. Remember, overall these reactions should be balanced in terms of charge, mass, and energy. So we're going to make sure that we balance our electrons correctly. So I'm going to try to get them both to 6 electrons. So I'm going to multiply the top half reaction by 3 and the bottom one by 2. And again, the goal of this is to make sure the number of electrons lost is equal to the number of electrons gained. All right, so now that I've multiplied that all the way through the equation, so I've multiplied everything, including the atoms and ions. So I have 3 put in front as coefficients now, and then I've multiplied the number of electrons and done the same thing with the nitrogen. All right. So now what we want to do is anything that's the same on both the left and right hand side, we're going to get to cross out and write kind of like our net equation. And again, this is kind of what we call the balanced skeleton redox equation. So 6 electrons are on both the left and right hand side, so I can cross them out, and then I'm just going to copy everything down. Okay, so this shows that it's balanced. I have the same number of electrons lost and gained. Even though I can't see the 6 electrons, I know if they're there, they've been balanced correctly. All right, now we're going to use the skeleton redox equation to fill in the balance equation. All right, now, a couple things I need to point out. As we go through our skeleton equation to fill in the coefficients, we have to be careful if we see something appear more than once. So here we have copper 0. This is where I have copper 0, so the coefficient is going to be 3. Now the next one is nitrogen +5. Because I have it in 2 places, I'm not going to use that 2. So you can kind of almost put like a dash or something through it to remind yourself, I'm not going to be placing that in for a coefficient. I then need to find copper +2, so this is where I have copper +2. Since its coefficient in the skeleton is 3, it's going to be 3 in the full equation. And then finally I find nitrogen 2, which is right here. Since it has a coefficient of 2, I'm going to place and rewrite it down here. All right, now that we've had that part balanced, you're just basically, the final step is to balance how you normally would. So I would go ahead and look to balance, let's see, the number of nitrogens, which means I need to put an 8 in front of HNO3 so that I have 8 nitrogens on each side. And then I can finally balance with balancing the oxygens, or you can look at actually balancing the hydrogens. And by doing that, I'm going to place a 4 in front of H2O. All right, well, that's really it. We're using oxidation numbers, half reactions, and then balancing out the number of electrons to get coefficients that we then place into this full redox reaction. So again, this builds on all the skills we've had, so if any of those prior skills are a little bit weaker, you might want to go back and practice those before we move on to this tomorrow.